Hi class, I'm hoping that after that last lesson where I said you have to have all the pairs of sides and all the pairs of angles congruent to prove the triangles are congruent to each other, I hope that this helps. And after we had that activity, I hope this will be great for you. So there are some shortcuts. In this lesson we're going to do a couple, and in the next lesson there's actually a couple more. For proving that triangles are congruent, the first one is called the side-side-side triangle congruency postulate, which I know that could be a whole lot to say and a whole lot to write out. So there's even a shortcut for this shortcut and a different way to write it. You can abbreviate it just with the first letter of each of those. So you'll see it written out as SSS. If you are saying that to me or saying that to somebody else, please still say side-side-side, just so we remember what we're talking about, but that's how you can write it on tests or quizzes, on homework, you know, whatever you're doing. What that says is it says that if you have three congruent sides in one triangle congruent to three congruent sides in another triangle, then the triangles are congruent. And I'm kind of running out of room here, but that essentially is what it says. And probably this picture would be the best thing for you, and that's why I threw it in here. Just having those congruency marks for all of those different sides, that's going to let you know that these triangles are congruent. And if we write out a congruency statement for these, again, it doesn't matter the order of whatever triangle you want to put first. I'm just going to put like A, B, C. Just make sure that you have these matched up. And if it's hard to tell which angle matches up with angle A, one thing you could do is you can look at the congruent side markings. A is in between the one that has 1 and 3 dashes. So just look for that same angle over here. So angle A is going to be congruent to angle D. Angle B is going to be congruent to angle E. And I put that one second, so I'll put that second. And then lastly, C and F are congruent. And you would know that all of those angles are congruent also because those triangles are congruent. That's just an example of that. CPCTC, corresponding parts of congruent triangles are congruent. The next one is called side angle side. And this is so important that you have them in that order. Because that angle has to be, I'm just going to write out that the angle has to be the included angle. And if you want to maybe just sketch out an example of this real quick, I'm not probably going to write out the whole postulate for this, but if I'm looking at this and let's say I'm talking about like this side and this side, the included angle is the angle that's like right in between those. The included angle is the one that those sides form that angle. And it has to be this way for this to be the reason of side angle side. Maybe I will kind of scribble it out here if you want to write this down. If not, really this picture just kind of says it all. But it would say that if two sides and their included angle of one triangle are congruent to, I'll just say the same, it has to be two sides and their included angle in another triangle, then the triangles are congruent. And we could write a congruency statement out for this if we wanted to. You would just write out that triangle ABC is congruent to triangle, let me see, I'm having a hard time reading this, it's so small. It's probably small for you too. Hopefully you have that note-taking guide. This would be DEF. So looking at that then, you could say that those triangles are congruent. And you would also know that any of those other sides and any of those other angles, once you knew the triangles were congruent, would be congruent also, because of that corresponding parts of congruent triangles are congruent, or CPCTC for short. Can you tell we love abbreviations? So here it is, the moment you've all probably been so excited for, the examples of the proofs. Looking at these, they will give you information just like they did in the last section. They may or may not give you congruent sides or congruent angles, but they will always give you enough information to say which sides are congruent or which angles are congruent. And they have to have valid reasons. It can't just be because they look like they're the same size, because after the triangles are congruent, yes, they will all be congruent, but we have to have reasons to say why in the first place. So I am going to do one as a paragraph proof and one as a flow proof again, or sorry, one as a 2-column and one as a flow, just so you can see again what the differences are. I'm going to do this first one as a 2-column. I really like 2-column proofs, but I'm starting to really like the patterning of the flow proof for these, because it lets you make those direct conclusions. So I'm going to kind of write this 2-column proof out in that style, where I don't just start by writing out all of the given. I'm just going to write one at a time, and then we're going to go from there. So this first one says that this is isosceles. So this triangle QRS is isosceles, and it tells me that QR is congruent to SR. So it's going to be important that you label that on the picture so that you know where the locations of these things are. And then I'm going to, there's nothing else I can really say about this at this point, so I'm just going to kind of go on to the next step and see if there's anything that this allows me to say. So this tells me that RT bisects QS at point T. And that's given also. So that doesn't actually give me like these angles or these sides. It doesn't specifically say that, but it allows me to tell something about this. So if RT is bisecting QS at point T, well, that means that T is the midpoint, but more importantly, that means that QT is congruent to TS. And this kind of directly lets me say that. In a flow proof, you would have an arrow from that box to this next one, where you say that QT is congruent to TS. And you could just write, that's the definition of a segment bisector, or again, if you just want to write bisector, that's fine. For this next one, there's nothing else I can do except for look at the picture to come up with another pair of sides or another pair of angles. And in this case, I know that TR is the same side for both of these triangles. So I know that TR is congruent to TR. TR in the left triangle is congruent to TR in the right triangle. And the reason for that is that's the reflexive property. You will see that probably like 1 in 3 of these proofs. So make sure that that's one that you know. Looking at this list then, it's so important that you go through and you mark. I always like to write it off to the side, so I just remember this is 1, 2, 3 pairs of congruent sides. So I can now say that those triangles are congruent. And my reason at this point either needs to be side, 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 or side, angle, side. Those are the only shortcuts we know. And in this case, I have all 3 pairs of sides congruent to each other. So I'm done with that. For this next one, again, I'm going to write out the given, and I'm going to write these out in 2 separate boxes. You could actually make them 3 separate ones, but I'm going to include the GH congruent to KJ and HL congruent to JL in the same box as given. And again, you have to mark this on your picture so that you have some idea of what's going on. Especially as we get more of these, it's going to be really important that we see the exact location. The next one says that L is the midpoint of GK, and that's given. And then because of that, I know something else. Since L is the midpoint of GK, I know that these two segments are congruent. So GL is congruent to LK, and this is the definition of midpoint. And now this is really all I need. I could even make it flow this way so that I have room. But do you see that I've said all three pairs of these sides are congruent to each other? So I could say that triangle GHL is congruent to triangle KJL, and that is because of side, side, side also. I'll go back and do a 2-column proof for this one. And again, it doesn't really matter to me which one you do it. It says the wings of one type of moth form 2 triangles. Oh, this one actually says write a 2-column proof, so let's go ahead and do that for why these are triangles are congruent. And it tells me that if EI is congruent to FH, and it says G is the midpoint of both EI and FH. So I'm looking at this, and I know that G is the midpoint of both of those. So I can do some work here to say that, well, if this is the midpoint of those, I can say two different things actually. Since G is the midpoint of FH, I know that those parts are congruent. And also, since G is the midpoint of EI, I know that these two parts are congruent. I accidentally put an extra mark on there. I probably could have just added a third one to that other one. That would have been faster. Oh well. So here we go. I'm going to really just write this part out because it's not going to really matter so much that these are congruent. I'm not going to need that in my overall scheme of things. I'm going to write out that, I'll change the color here. G is the midpoint of EI and FH. And you won't always have both of these. Make sure that you're doing it for whatever one it says it is. And that's all that you do. We'll do some examples like that so you kind of know what I'm talking about. I'm going to do these in two separate colors just so you can see it better. So since it's the midpoint of FH, I know that FG is congruent to GH. And because it's the midpoint of EI, I know that EG is congruent to GI. And both of these are definition of midpoint. So I'll just put them on the same step, but you could have two separate steps again if you'd rather, call that 2 and this one 3. They just have the same reason. I don't have a reason why these two segments are congruent. Yes, they would be, but I don't have an actual reason for that. But I do, however, have a reason for why these angles have to be congruent. So I could say that angle FGE is congruent to angle HGI, and that's because they're vertical angles. So vertical angles theorem is what you write down. And now this is an example of these triangles being congruent because of side, angle, side, where you have the two sides and the included angle, and that is that. One more. This one may actually be faster. I'm going to go through graphing these pretty quick. It may be quicker for you to just go ahead and graph them on your own instead of trying to follow along exactly where I have the dot. Either way that you want to do it, I guess, is fine. But again, I'm just graphing these different coordinates. I'll even use my straight line tool to make them look a little nicer for these triangles. But you just go ahead and graph these two triangles. I'm going to do them in different colors also. And we want to tell, the whole goal is to tell whether or not they are congruent to each other, and have numbers be a proof for that. So make sure that you label these two with the points. -7, 1, and -4, 4. So it's not going to be good enough that maybe they just look like they're congruent. We're actually going to have to go through and write a little reasoning for that. I'm looking at this then, and looking at them, well, the first part says graph both in the same coordinate plane, so check, that's done. For part B, it says use your graph to make a conjecture, so we're just kind of making a guess as to whether or not these are congruent. I think they look like they're pretty congruent, so I would say, yeah, they look like they're congruent, and the reason is because it looks like all the sides are congruent. And I guess what I mean by that is all the pairs of corresponding sides look congruent. And it actually doesn't look like they're that far off within themselves being congruent also. So then part C, this is the part that's not going to be the funnest, but it is necessary. It says write a logical argument using coordinate geometry, so using the actual points on here to support the conjecture we made in part B. So because I said that yes, it looks like these are congruent, I'm going to have to go through and figure out the actual lengths of these to say that they are in fact congruent. So I'm just going to take a second. You don't necessarily have to do this, but just put the different coordinates on there real quick so that we have those, because we will be using the distance formula. And we will be using the distance formula several times. 6 times to be exact, because in order to prove this, you need to prove that all the pairs of sides are congruent to all the pairs of sides in this one. Again, it's not good enough just to say, well, it looks like it, and then that is that. So it doesn't matter which one we start with. I'm just going to start here, and the length of JL, when I'm using the distance formula, remember you're subtracting the x values, squaring that, subtracting the y values squared. So I could do 5 minus 2 and then 2 minus 5. And I'm not going to go through every single step. I'm just not going to have enough space here. But this is going to be 3. 3 squared is 9. And this is going to be -3, and -3 is also 9. So it's the square root of 18. And I would just leave it like that. I wouldn't bother to figure out the decimal, because that's not going to be important in the end. It's just going to be important that the corresponding sides match up. If I find the length of KL, again, difference of those x values squared, so let's do 2 minus 1, and the y values squared, 1 minus 5, and it doesn't really matter the order that you're subtracting these, because you're going to end up squaring them either way. So this is -1 squared, which is +1. This is -4 squared, which is +16. So this one is the square root of 17. So again, super close for these, just not exactly the same. And then the last one I have to do JK. And for this one, the difference of the x values squared, difference of the y values squared. So I have 2 minus 1 and 5 minus 1, and you may already notice that this is the exact same thing. This is going to be 1 plus 16, which is the square root of 17. So this actually ends up being an isosceles triangle. I know some of you guys are probably looking at this and you're saying, well, I knew that because I kind of looked at how far they are. But again, the whole thing is we need to actually write out how long these things are, even if that does take a little bit of time. If this were a test question, it would be worth multiple points, so it'd probably be worth, your time doing it. For this other triangle, it doesn't really matter where you start. I know that this is the one that's congruent to the first one, so I'm just going to start there. PQ. Difference of the x values. I'll kind of simplify this for you. Difference of the x values, the distance between -7 and -4 is 3. 3 squared is 9. The difference of the y values is 3. 3 squared is also 9, so that's going to be the square root of 18, and that's one pair out of 3 that are congruent. It's impossible really to tell what side these other ones correspond with. It's not going to really matter. We have Qn. Distance between the x values is 1. 1 squared is 1. Difference between the y values is 4, and 4 squared is 16. So that's the square root of 17. And then the last one there, Pn, the distance between the x value, or the distance between the x values is 4. So that's going to be 4 squared, which is 16, and the distance between the y values is 1. 1 squared is 1, and that's the square root of 17 also. So you can see here that we've written an argument. I should actually probably write something out. I'll write out since all 3 pairs of sides in one triangle are congruent to all 3 in another, then the triangles are congruent because of side, side, side. And there you go. That is it.